Hi, and welcome to the next part of this video series. During our last episode, we created the swap chain and its buffers. We created a RenderTarget view descriptor heap where the GPU pipeline and also the CPU can find the references to our buffers on the swap chain. I wanted to do some basic output stuff. I'm sorry. During the last episode, but it spanned an hour, and yeah, I decided to end the video right there since since it had taken a long time. We would like to test our things out whenever we um, um, present or get our pipeline ready to present our current back buffer after we have done rendering to it. Before that we will simply clear it. We will try out using a clear color of black. But suddenly, as I decided that I wanted to do that, I realized that our command list here needs a way of kind of like returning not a command list but a graphics command list, since that's what we record our that's the interface that we record our commands from. So we will do a few changes. We will do an inline function here where we return the interface of a graphics command list pointer. And we will simply call it command gfx command, and this will return our pointer here. But cast as a graphics command list. Since we are allowed to cast our command list to the graphics command list, we can simply do that whenever we want to do a graphics call. We will use the call as you saw in the wrapper. We will do command list gfx command, and we will do a clear render target view, and we need to excuse me, supply a D12 descriptor handle on the CPU side. CPU descriptor handle. As you saw during our last episode, the swap chain will actually be able to supply what is our current render target and what the handle is to that. So let's get the handle from our swap chain. By getting our method here. And our render target will take that handle. It will take our color, which we just set, the clear color. And then it would like some information about the number of rects that are specified in a pointer afterwards. We don't have any such kind of stuff. So therefore, we won't do that. The problem is that we might end up in a situation where this may get called before we can initialize anything. Let's see. We might have an error here. Yeah, we did. Let's see, does it relate to... Well, okay. As you can see over here, I talked about that in a previous episode, our memory usage just keeps increasing, which means we have a memory leak. That is because we keep on recording this command to our command list. That's not great. We also need to couple our command Q and our command list. And our command Q here has a method where we can call execute command lists. We can specify the number of command lists. We can specify one, and we can specify our command list. And let's see. It wants it to be const. So let's just cast it. Let's see. Doesn't this work? Well, okay. Let's see. Usually we need to do this instead, perhaps. Yeah, there we go. This will probably crash. No, as you can see here, it will also crash, but because we haven't handled our stuff correctly. Anyway, as you can see here, we must close the command lists before we execute them. This was a demonstration of our D12 debug layer. So we will ask our command list to get the pointer here. Okay, it probably also needs to be called on the GFX command list. Oops. Close. Let's see. The stuff can't be, let's see, can't be called on a closed command list. So now we need to open it. Yeah, okay. We would actually want some method on the command list here in terms of resetting the allocator. Reset command list. Where we simply reset the allocator and call a reset here. Mind you, this is not a release, it's a reset. And we call the GFX command here to reset also this. Again, it's not the com pointer function. Let's get the allocator, supply that, and a null pointer for the target pipeline, standard pipeline state. And we of course need to call that function afterwards. Reset command list. There we go. Now nothing happens, but let's see what our error message is. As you can see, the system whines that we're trying to reset the command list allocator before it's done using it. So this basically means that our between these two steps here, on the CPU side, everything is happening too fast. So we need some kind of wait method to handle that. And we can simply do something like while our command queue get fence get completed value is lower than our command queue current fence local value, we call the pause intrinsics. Let's see, we still have the same problem. Using rendered, yeah, so the problem is that we haven't transitioned the resource state, as I mentioned. I would think it was during the last part of the episode before. So you might remember that I said this might give us an error, and that's because we need to handle the resource state. The resource state is common, and we want to set it to the appropriate resource state. For that, we need a resource barrier. A barrier, as you might recall, controls a resource state. Let's do a resource transition here. Let's do a zero flag thing. And we need some information about our resource. Which resource do we want to change? Let's do a null pointer for now. The sub-resource can usually the sub-resource is an integer, I think. Right. Yeah. We will not care about that. We will also set the state before. Actual state, comment slash %. So this will be our % state. d3d12 resource state %, and we want to transition it to the state after, where it's the render target. The problem is that we not only want our handle here, we also want the actual resource. So we would like a way to get a resource pointer as well. Let's do this inline, where we simply get current render target, where we return the render target's current buffer, current buffer address. There we go. Not application, or render API, yeah. So let's set that to our swap chain here. Get current render target. Afterwards, we would like to be able to actually in part do the % stuff, and then kind of like when we clear the render target, we of course need to actually do this. Let's see, we will ask our command list here to do a gfx command where we transition. Isn't that it? Let me see. As far as I remember. Okay, it's the resource barrier call. We will do one, and we will change this barrier here. That will be done before we write anything. Then we want to ask our swap chain to present whatever we did with our render targets. Let's see. No, that will be done after we have done closing the command and executing. Then when we are sure that everything is done, we can actually reset the command list. When we do this, we would like to transition the resource back into a present state. So we set it to a render target state. We try to clear the color of it. Then we set it back to the present state. Then we close the command list. Let's see. Then we close the command list, execute the commands, try to call present, and we wait for the allocator to be done, slash not be in use, and we try to reset it. Let's try to see if that compiles. And you can see now we have a black screen. We still have some errors in the background, but at least we actually managed to do something with our application. Everything still crashes, and that is because we have some commands in okay, let's see. When do we start running into problems here? Let's see. And the problem is probably that we don't increase the fence value, therefore we have no waiting. I'm pretty sure that's the problem. Yeah. So we would actually like a wrapper for this call here. Let's see. We would like something like a internal execute command list, and let's just take a pointer to the command list that we actually want to execute. We will execute the command list in our bundle here, and as you remember, it wants a constant pointer that doesn't change. This is kind of hacky. Let's see. and it actually expects the address of the address. Also, we want to increase our current fence value since we know that we are executing a command. So we know which fence value to wait for. We will also tell the pipeline that whenever this series of calls gets done, set this fence to our current fence value. So on the GPU, whenever it's done doing this execution here, it will increase the underlying fence to this value. This means that the CPU can always wait for our actual fence value to reach the current fence value stored internally on our command list wrapper. So right before we weren't actually doing any waiting. Let's see, m execute command list, m command list, get the pointer to that, and we might now have sufficient synchronization. As you can see, we have no errors anymore. During our application runtime, we have a black screen, which means that our clear color is doing great. We still have a crash because, as you can see here, we reference an object that is in flight on a command queue, i.e. our render target. So this means that whenever we close our application, we actually want to quote unquote flush the command queue, and of course make sure that we are not rendering anything in particular. Okay. But we will fix that later. I was about to show you that this actually is because we are doing something to our render targets. And as you can see, I managed to clear the color red. We can even do something that epilepsy warning here. Don't watch this if you have any of such problems. We will do a current index, which will be 0. Let's do test variables here. Temp test vars. During each update draw, we will set this to its own value divided by 2. Or rather, wrapped around 2. And we will do a call here. If it's 1, we do this. Otherwise, we do black. As you can see, we had some flickering in the start. I actually think we still have flickering, and if I resize it, move it, you can actually see the swap chain pausing for a bit, and actually swapping between the black and red color. Yeah. So this actually works. Let's just clean up the code here. The last thing that we want to do is to make sure that whenever we do like this, whenever we call release on the application, we make sure that nothing is in flight. Let's see. Oh yeah, okay. The flushing is actually let's see. So during our swap chain here, whenever we call release, we drop the buffers, drop the stuff before we call release on the swap chain. We make sure that everything is done. Let me see. Maybe we want to do some extra flushing. We might have, yeah, okay, we can do a function here that is called flush hue. That is basically where we kind of tell the command queue to flush. Let's see. We can ask the system to perform a fence. Let's see, signal to the fence, where we will ask it for our current value here, +1. And we will do this for as many times as our G max swap chain buffers. There we go. Okay. Flush the queue. And I think we should be good now in terms of not getting any crashes. Okay. Well, maybe it's because we simply exit the application. No, that doesn't. Let's see. Mm, 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 mm. Yeah, it pertains to the way that maybe we want to wait for the fence anyway. Let's see. Maybe it's the order that we do the releasing in. Okay. Nope. Maybe it's because we don't want to close the application the way we do. Because why would it why would it even call that part of the update step? I mean, it's a minor bug, but I want to fix it. So when oh, maybe it's because they go out of scope too early? Maybe we want, well, we did that before. Um, it's like it's crashing there every time. Does it do a, well, it should only do this draw call. If ever we're running. Let's see if we do a check. Uh, Nope. There's some bug here in terms of the way that our calls get ordered. I won't end this episode on a bug. I think this is fine. We aren't running in our application. We will call on destroy. How can we actually, let's see. So if we set a breakpoint here, we do not have a problem yet. Let's step into this. How do we end up here? Well, it's obviously related to the running clause. We shouldn't be running update after we posted the let's do, if we are running, we can do the update draw step. Okay, let's see. How come? Oh, wait a minute, wait a minute, wait a minute. I know why. If we actually have a command queue, because this gets called again, that is why. No need to try to do it twice. We could also do a check inside of this if it's even valid. Then we do this, otherwise it's not valid. Let's just do like that. Whoops. So it was because the post quit message got translated, and then we ended up in a update draw call again, even though our application wasn't running. Yeah. Let's see, do we have any live objects? No, we don't. Okay. So during this episode, we made changes to our command list structures. We added the method to reset the command list allocator, and then resetting the command list itself via the graphics command list call, where you need to specify which allocator to use when the command list is reset. We also did some functions on our command queue, where we when we want to execute a command list with our internal wrapper function, we take the command list that we want to submit, we submit it to the queue, and we expect to wait for a fence for this specific frame. Since we at frame 1 will generate frame 1, we increase the fence value to a 1, and we will tell the fence or rather tell the command queue that whenever it's done with the work on this command list, uh, it should signal the fence that we have achieved this fence value and update the fence value. We added a flush queue function in terms of closing down the application in case we need to do that, where we make sure that for every potential buffer in flight, we simply do sudo work on the command queue. We tell it to wait for this. Let me see, maybe I actually should uh, let's see, maybe I should have done a multiplicative. Yeah, it's not +1, it's plus I. Anyway, we tell the command queue to signal the fence whenever it gets to these values. Since there are no commands, it will reach the fence fairly quickly and simply flush the command queue. Nothing will be inside the command queue. Yeah, so we changed that. Added some functionality. So now we have also a update step where we take our current render target from our swap chain. We transition its state so that it's not a present target anymore. The first time it's used, it's in the present slash common state, but that doesn't matter. And we set it to a render target state. We tell the command list that we want to make this transition. Then we get the pointer to our current render target, and we store a command that tells the that records to the command list that we want to clear the render target with the specific handle to the specified clear color. We have a test variable here that we don't need. We then do another barrier transition on still the same render target. Now we don't want to render to it anymore. We want to present it to our screen. Therefore, we record this resource transition. And since we feel like now we're done in terms of recording commands, we close our command list and we send it off to execution, which was the function that I just showed you. Then we want to present our current render target to our screen. Then if our CPU is too far ahead of our GPU, we will wait for it. And then when we are certain that there is nothing in use in terms of the command list recordings and the specific command list allocator, we of course reset that. We can only be certain whenever we're sure that the CPU is not too far ahead, since we only use one command list. If you had several command lists, you could of course do more work. When we close our application, we check if we need to flush, we release our swap chain, our command lists, and so forth. We also changed this part of the application. We only want to do the renderer update draw whenever we are running, since it will give us a lot of different null pointers if we don't do that. Since we on the message destroy start the releasing process of the renderer resources, it would be only be wise to check if we already set this flag to false and therefore shouldn't do another update draw call. Yeah, that's it for this video, minus debugging and everything else. It took about 45 minutes and we now have output to our screen. We also have a simple pipeline in terms of doing graphics commands and record them. So we're basically ready to dive into more in-depth topics in terms of DirectX 12. These are the fundamentals in terms of resource transitions and recording of commands. Yeah, but we will of course need to couple pipelines and shaders and a lot of fun stuff, so that we can actually do something else than just clear the render target with a specified color. So yeah, we will do that in future episodes. I think that this will be it for today. If you found any of this helpful, inspirational, entertaining, or something else, please leave a like, comment, or even a subscription. Feel free to check out my other live streams and make requests in terms of this content. Hopefully I'll be seeing you around. Thanks for tuning in and take care. Yeah, and oh, by the way, the repo will be updated, of course. All right, take care. Bye-bye.